Physics experiments involve the measurement of a variety of quantities, such as length, mass, and time, and a great deal of effort goes into making these measurements as accurate and reproducible as possible. The first step in ensuring this accuracy is to define the units in which the measurements are made. There are several systems of units for us to choose from. For example, there's the SI system, the CGS system, and the BE system. The SI system, or System International, is based on the meter as its unit of length, the kilogram as its unit of mass, and the second as its unit of time. The CGS system utilizes the centimeter, gram, and second for length, mass, and time respectively, and the BE system, or the British Engineering System, uses the foot, the slug, and the second. In this course, we will use the SI system. Originally, the meter was defined in terms of the distance measured along the Earth's surface from the equator to the North Pole, and then more accurately is the distance between two marks on a bar made of a platinum-iridium alloy. Now the meter is even more accurately defined as the distance light travels in a vacuum in 1 divided by 299,792,458 seconds. This definition is used because the speed of light in a vacuum is a universal constant. You will learn more about the speed of light later on in the course. The definition of the kilogram, a measure of mass, has changed over time as well. As we will see later on in Chapter 4, the mass of an object is a measure of its tendency to continue to move at constant velocity. The kilogram was originally defined in terms of a specific amount of water, and today 1 kilogram is defined as the mass of a standard cylinder of platinum-iridium alloy. And finally, time, which like length and mass, has been defined differently throughout history. Originally, the second was defined in terms of how long it takes for the Earth to rotate once about its axis, with 1 day being said equal to 86,400 seconds. The Earth's rotation was chosen since this motion repeats over and over. Today, the second is defined in terms of another repeating process involving the element cesium-133 in an atomic clock. The atom emits electromagnetic waves, which you will learn about in chapters 16 and 24. And the second is defined as the time it takes for 9,192,631,770 of these wave cycles to occur. The units of length, mass, and time, along with a few other units to be defined later, are regarded as base SI units. The word base is used since these units are used with various laws that will define additional units for important physical quantities like force and energy. These units are referred to as derived units since they can be written in terms of the base units. The value of a quantity in terms of either derived or base units can be a very small or very large number. It is often convenient to write these numbers as multiples of 10 using scientific notation. For example, 1,000, or 10 to the third meters, are referred to as 1 kilometer, and 0.001, or 10 to the minus 3 meters, is called 1 millimeter. For more review on powers of 10 and scientific notation, you can consult Appendix A in your textbook or ebook. Since any quantity such as length, mass, or time can be measured in different units, it's important to know how to convert from one unit to another when solving problems. We'll take a look at this in the next section.